In the sport of curling, a heavy stone is projected across a horizontalized surface. One player projects a stone of weight 180 newtons, which moves 36 meters in a straight line and comes to rest after 24 seconds. After the instant of projection, the only horizontal force acting on the stone after its projection is a constant frictional force between the stone and the ice. Calculate the deceleration of the stone. Find the magnitude of the frictional force acting on the stone, and calculate the coefficient of friction between the stone and the ice. So there's the question then. Okay, so here's the forces in question. There's a resistance force due to the motion until it comes to rest. So it comes to rest in 24 seconds, a distance of, so its initial speed is u, its final speed is 0. So we've got u, we don't know, we've got the final speed is 0. We know that the s is equal to 36. We know t is equal to 24. We don't know u, so we need to find the acceleration. Yeah, so part 1 then. If we use v squared equals u squared plus 2as, gives, well, that won't give the, because we've got two unknowns here, the acceleration and the initial velocity, so we don't want to use that one. So let's scratch that. So what else could we use? Well, we could use s equals ut, v equals u plus at. We'll have to use s equals ut. It's slightly awkward. S is equal to ut plus half at squared. We've got to use this one then. It looks like gives, so 36. The initial velocity we don't know, so that's u. Oh, we'll use vt. We've got to use vt. S is equal to vt minus half at squared then. 36 is equal to minus a half times the acceleration times the time squared. The final velocity was 0, wasn't it? So that tells us the 2 comes up to be 72. And then the 24 squared can move down. Is equal to a with a minus, isn't it? So the 2 went up there. 236 is a 72. The 24 squared went down. 24 goes into 72 3 times, doesn't it? So it's just 1 now. 3 times. 3 24s is 72. And 3 over 24, 3 goes into 24, 8. So that tells us that a is equal to minus 1 over 8. Tap it in the calculator if you need to. Meters per second. So there's a, the acceleration, or the deceleration. So the deceleration, ants, is equal to 1/8 meters per second. Okay, so that's the deceleration. Find the magnitude of the frictional force acting on the stone and find mu. So the force acting on the stone is equal to mass times acceleration. Gives, well, F, the force, which we want, is equal to the mass. Now the mass, the weight is 180, so 180 is equal to mg. So m is equal to 180 over g. So that's the mass then. So 180 over g times the acceleration, which is 1/8 as a deceleration. So that goes in 4 of these, 45 and 2. So it's 45 over 2g. 45 divided by 2 times G equals 2.2, 2.30, 2.30, 2.2959, 2959, which equals 2.30 to 3 significant figures, newtons. So there's the force then, part 2, and find mu. So here we've got our weight, we've got our 180 newtons, so the reaction force going upwards must equal 180, mustn't it? Using F equals ma. This is mu r. So here, mu times 180 is equal to the force, 2.30, or 2.295. So mu is equal to then, is equal to 2.30 over 180. Now I've got that more accurate, haven't I? So I just want to, maybe I should put that, so let's just change that to 295 here and here. 2929. So divided by 180 then. Here it is here, divided by 180 equals 0.0127. And that's the 3 significant figures. Let's just check that then. 0.01275, isn't it? So it's 0.0128. So we need to just put, instead of a 7, it's an 8 here. And that's the 3 significant figures.